Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to see about Introduction to Biomedical Signal Processing. So first DSP. What is DSP? Digital Signal Processing. So digital signal processing is a numerical manipulation of signal, usually with an intention to measure or filter or produce or to compress the continuous analog signal. If you take a biomedical signal processing, the same signal will come from a biomedical background. It may be ECG, EEG or any other signals. Then it will be called as biomedical signal processing. That performing some operation on the biomedical signal is called biomedical signal processing. A signal is a physical quantity that varies with time, space or any other independent variable. Look at this. This is an audio signal. With respect to time, it is an voltage will be varying. So classification of signals. So depending upon the nature of the independent variable and the value of the function, we can classify the signal into following types. So first one, scalar signal. A signal generated by a single source is called scalar signal. Vector signal, or we can say it is a multi-dimensional multi-channel signal. A signal generated by multiple sources, that is more than one source, is called vector signal. One-dimensional signal, a function of a single independent variable, then that signal is called one-dimensional signal. Multi-dimensional signal, a function of more than one independent variable, that is the multi-dimensional signal. So continuous time signal, the independent variable is in continuous manner, then it is called as continuous time signal. Discrete time signal, the independent variable is in discrete manner, then that signal is called discrete time signal. Analog signal, a continuous time signal with continuous amplitude is called analog signal. Quantized boxcar signal, a continuous time signal with discrete value of amplitude is called quantized boxcar signal. Digital signal, a discrete time signal with discrete value of amplitude, then it is called as digital signal. A system may be defined as a physical device that performs an operation on a signal. If it processes that signal, then it is called as a systems. So we can classify into four different types: analog system, digital system, continuous time system, discrete time system. So if you take a system, both inputs outputs will be in the same manner. If you take an analog system, the input and output will be in analog signal. If you take a digital system, both input and output will be in a digital form. And continuous time signal, the input output will be in a continuous time signal. Discrete time signal, both the input and output for the discrete time signal will be a discrete time signals. Yes, signal processing, yes, signal carries the information, then we need to perform some operation to extract that information. Performing some operation on it is called as signal processing. The objective of signal processing to extract or to enhance or to transmit the signal or to store the signal, we use this signal processing techniques. Digital signal processing, the implementation of signal processing in a digital domain will be called as digital signal processing. The need for digital signal processing, analog signal processing having following drawbacks. First one, they are sensitive to environmental changes. That means whatever the changes in the environmental temperatures, for example, if we take it is in a different temperature condition, normal room temperature, if it is in 0 degrees Celsius, the entire performance will be changes because the conduction of current depends on that free electrons. So due to temperature variation, due to the negative temperature coefficient, the free electrons will be varies, automatically performance will be varies. Aging parameter. So if you take any components, due to aging, the performance will be degrades in analog. Third one, uncertain performance in production of units. So that we cannot expect the same performance for all the units. Again, variation in performance of units. So each unit may produce different results. Costly of the system will be high in analogs. Scalability means whether it can be scalable for different things. It is not possible in an analog system. To overcome this only, we go for a digital system. So taken is the different type of analog system and digital system. So look at the first one. This is an analog signal processing system. So input will be given as an analog input for, and output also we get it in analog signals. So the real world signals are already in analog manner. So automatically we feed the input directly to the analog system and we get the output from the analog system. Look at this digital signal processing system. So the real world signal is not in digital, so we need to convert a digital form to process the data. That's why look at this analog input signal. A to D converter is used to convert from analog signal to digital signal, so that will be fed to this digital signal processor. So the output of digital signal processor is in digital form, but real world signal we need an analog form. Then we use this conversion D to A converter to get an exact analog output.